Welcome to the human ear and specialized organs that allow us to hear and maintain our balance.
Well, hello again. I want to show you our anatomy of hearing experience. This is a great example of why it's beneficial to use full CGI VR for even the simplest version of experience that we create, which is information presentation. You'll notice that all we're doing here is basically giving a lecture on anatomy and its functions, but we're doing it with a nice set of 3D assets and some animations. The difference is we're giving the student an experience that's simply not possible if we were just doing 360 video. I can't actually shrink the camera down small enough to stick it inside someone's ear, and even if I could, you still wouldn't be able to see sound waves and look inside their cochlea while their basilar membrane vibrates. As always, we're embracing the VARC method. Obviously, this is very visually compelling and you're hearing the explanation of what the images represent, but we're also displaying the text on key words, so you're reading important information as it's being spoken to you.
Action potentials are the long-distance signals that send messages to the brain via the auditory nerve when a sound has been made.
Now, arguably, the act of feeling like you're in the environment is kinesthetic enough, but we also have these pauses between sections where they can directly manipulate the models and explore a little bit firsthand. But ultimately, that's all we would lose if we made this a 360 video, just the little interactive part between sections. This could be a purely 360 video experience, and you would still get all the same information. However, building it in the game engine makes it easier for us to go in and add new things, change things, without having to animate a whole section, stitch that into the old video, then re-export the entire thing. Plus, all these individual presentations are their own little blueprints, and I'll show you more what that means in a second. Point is, if we wanted to fundamentally change this experience from a linear progression from one section to the next, we could spread these different actors all around the room and let you walk up to them and activate their presentations in whatever order you choose. It's still just an information presentation experience, but now there's a little more kinesthetics to it, and of course, we can always throw in some additional infographics and documents and stuff that you could click on and expand the content, digging into parts that interest you in ways that we really just couldn't do with a 360 video without ballooning it in time and size. So I want to demystify what's going on here and show you a little of what's under the hood. This is our level. It's super basic with a background sphere, two little meshes with the squishy texture so you feel like you're inside some fleshy brain bits, a little fog, a few lights, and really only 3 actors. There's the pawn, which is our VR player controller. This little guy in the middle, that updates our text when we tell it to. And this spawn location, which just tells the different presentation actors where to show up. So most of the logic is inside these, what we call blueprints themselves. Here's the actor from the second part of the presentation where we saw sound waves traveling into the ear, vibrating the eardrum. Then we focused individually on the malleus, incus, and stapes. So each of these little bones lit up while we said their names. So here's that logic. Blueprinting in Unreal is what's called visual scripting. This is technically writing code and programming functionality, but instead of typing out script, we're building this flow chart which can get kind of large and unwieldy, what we like to call the spaghetti monster. But this particular blueprint is actually not doing anything super complicated. It's just doing the same thing many times over. Turning on and turning off the individual sound wave meshes, manipulating the eardrum animation, and highlighting the different bones in our mesh. Here we're using a basic timeline. All this does is let you manipulate some values over a period of time. So these are just floats, which is any number with a decimal point, and over the course of 25 seconds, we're taking this number and raising it up, then lowering it down, then doing the same with a couple other numbers. And those numbers are driving this glow value inside the material on the 3 different bones. So these bones all have the same material. They just have their own instance of it. Super basic material, just a few standard textures. Then we have this highlight color here, and we're manipulating it by the glow value. And that's the number we're changing with our timeline in the blueprint. Simply magnifying how intense this color is and then setting it back down to 0. Now, even though all 3 of these bones are part of the same 3D model, we have it broken up into individual material slots. So they each technically have their own material, making it possible for us to highlight them one at a time. We did the same thing with the outer ear. Even though it's a single mesh sharing one texture, we divided it up into 3 different material slots so we could individually highlight the pinna, convolutions, and ear canal. We can do a lot by manipulating textures inside the material too. Take for instance this sound wave animation. We've got the individual wavelengths of the sound, and it looks like they're moving along their path. This is actually just a solid, stable mesh that's not moving at all, and it's the material that creates that appearance of animation. Inside this material, we've got as simple a setup as possible, a color, and we've got this black and white texture, which is acting as our opacity mask. Super common, standard image editing tactic. White is visible, black is invisible, and anything gray is in between. So we have this simple half and half and this panner node moving the mask in the Y direction. So we're really just going from visible to invisible along the mesh, and that makes it look like it's animated. Last thing I want to look into, just to show how complicated materials can get, technical artist, shader, designer task is an entire career path all into itself. So when you math teachers get students like me who are complaining about graphing curves and f of x and all that, you can tell them that all those cool looking shimmering surfaces in the video games they love to play are all being driven by graph math. Anyway, inside the cochlea we have this cool gooey watery look. There's actually 2 meshes, the outer shell, and then we have another that's just offset, right? Same mesh, just a little bit smaller inside it. So when we fade out the pink shell, we see the liquid on the inside. But this liquid is really just a blend of 2 colors. And you can see we have all these different numbers here deciding how this blend ends up looking. If we take a peek inside the material, you can see it's just being driven by a handful of functions. All the movement and blending is happening inside the few blue nodes with all our numbers pumping into them. So these functions are where the math happens, and they can get incredibly complicated in how they play with the data, but we're really just feeding it 1 texture, 2 colors, and some numbers to do its magic with. If you look at this list on the right, these are all the built-in functions that come with Unreal. So you could spend years just finding cool stuff to play with and digging into how they work before you ever bothered trying to come up with functions of your own. Also, quick note, since we have a super simple environment in here, I can just disappear this floor and ceiling mesh by checking the hide in game box, then turn this fog off by setting it to 0. Got a little secondary fog here to 0 out too. And since we're already using that inverted sphere that we use for 360 video, I can play a video on this instead of the textured environment. And now it's a 360 hybrid experience because we've got interactive CGI elements, but the background will be 360 video. All I have to do is change the material. So in this folder, we've got a few things. We've got a reference to the video itself. We've got this media player asset, and I've got it set to tell my video to play an endless loop. This media player is writing the video onto this texture, and this material is using that texture. So we pop the material on the sphere, and the only other thing we have to do is go inside the level blueprint, and we'll make a media player variable, tell it to reference our media player asset, and when the experience starts up, we tell it to load our video and hit play on it. So now we go into VR mode and voila, we're doing interactive information presentation as a 360 hybrid experience. And now I'm learning anatomy inside inside a clinical type environment that we didn't have to build, and there's a bunch of characters in the background we didn't have to animate, and they're doing whatever it is they're doing over there. Information presentation, either as pure VR experience or 360 hybrid.